Ready for a deep dive around evaluation? For the next hour, I want to go through how we evaluate generative AI applications. This video is really intended for folks that are doing Gen AI early, the first time, or folks that are thinking about how I communicate this to a broader audience. I have other videos that go more into the technical depth of some of these topics, but really what I want to do today is help motivate why we care about evaluation. We're going to walk through kind of a very standard evaluation problem to make sure everybody understands how you should be thinking about it. I will spend a little bit of time on agentic flows as well because there's a lot of interest and we want to talk about how what we're doing will translate over to there. And I'll deep dive into a few areas, but we'll save a lot of the deep dives for other videos. Now, this is a version of a talk I recently did for ODSE, the Open Data Science Conference. I'm going to go a little quicker here in this video since you can fast forward or stop and pause, rewind, as well as I'm going to leave out kind of some of the jokes, some of the kind of the things I do in a regular talk versus here. So let's start by kind of motivating why we care about this. A popular use case for generative AI is composing emails, generating lots of customized, tailored emails to do that. And we can use GenAI to do that by taking advantage of, for example, a simple prompt that can write it. This use case seems very simple. We've all used ChatGPT to produce content as well. And if you try it out, you can do this very easily where you can build a customized email. And many of you might think, hey, this is great. I'm done with this project. I can move on to my next problem. Now, what's going to happen, though, is when you try to push this out to production, you're going to find things out where your query might be one thing, but it's writing something that's totally different. Or maybe it'll hallucinate and make up information that wasn't in the original thing. These are some of the common things that can happen, but this stuff has happened in real life. So Cursor, for example, had its support GenAI bot start to create a new policy. The new policy said you could only get one device per subscription. No, with Cursor, you can get many more devices. But that policy led people to believe that was the true policy and actually led to a number of cancellations and had financial and reputational consequences for Cursor. That's what can happen with your GenAI bots running around like that. Now, generative AI is more than text. You can create images. If, for example, the images you create look a lot like the images that somebody else owns, in this case, Getty, that's another concern that you might have for copyright concerns. Other pieces is courts have held that what your GenAI bot says is no different than what your employee might say. And so if your employee creates a policy, your company's held to it. Same thing with your GenAI bot. So as you start thinking about generative AI, and this is where companies are often very reluctant to put these things into production in front of external customers because it's scary. There's a lot of risk of mistakes. And why a lot of people have GenAI projects that are internally only and aren't pushing them out to the public. Now, it's important you do GenAI because you need to understand how your applications work. You need to, sorry, I'm going too fast. You need to understand for evaluation why your application is working and not working. So you need to do evaluation for that. You're also going to have to convince other people in the organization, your manager, other stakeholders that, hey, the thing that you produced is worth it. So evaluation will give you the data that you can use to show them that, hey, I've tested this out. It really works like this. And finally, sometimes for some of you are going to have to go out and reach out to regulators and show that your app works across there as well. And the feedback from executives has been concerned about GenAI, where we've seen, for example, many GenAI projects sit at the demo stage, not move to production, concerns about cost and accuracy with that there. And this was from kind of a year ago. There's a more recent report from IBM that had executives saying similar work as well. So let me show you how we can tame this, how we can start thinking about Gen AI. Now, I think there's 3 things I want you to think about as you organize your head around evaluation. One is, because I'm going to use this analogy of dragons, because I like dragons, they're fun, and dragons are wild, they can do a lot of amazing things, just like Gen AI. But in order to really kind of use dragons, use them effectively, you got to understand your terrain, you got to have a map. Same thing with Gen AI. You're going to have to understand your data, the technical flows, how everything moves through, because that's going to give you all the knobs that you're going to be able to use to improve your applications. So that's one piece. The second is just like a dragon can fly way up in the air or it can come down to land, as we'll talk about when we're thinking about evaluating, seeing how well our applications are working, sometimes we need that sky high view, sometimes we need to come down local. All of this will come out to you as well. Finally, we have a lot of tools we can use with dragons. We have a lot of tools we can use with Gen AI, and I want to go through some of the trade-offs of all of those as well. Now, this is the second part of a longer talk that I've done. I did the earlier talk about a year and a half ago where I went through a lot of different methods that are available for Gen AI to be able to use. So a lot of the knobs that you can work with. A lot of that content is still out there, very relevant, very useful. I'm not going to rehash all of it. I'm expecting that you'll go and see that video for that. But it's been a year and a half. There's some kind of trends that I want to point out. Also, I think a gentler introduction to evaluation is also a good companion to that as well. And so that's what I want to tackle today with this. Now, you might think, how hard can this be, especially if you haven't been kind of growing up in Gen AI? Evaluation is just seeing how good something is. Can't I just trust the data? Right? Like when Anthropic has to decide between, should I stay with Claude 1? Should I go to Claude 2? Well, why can't they just have established data sets that they run, assess that on the data sets and see that and have a very data-driven process? Makes a lot of sense. But when the folks at Anthropic tried this, the Claude 2 looks better on the benchmarks, but when they actually asked humans, the humans thought differently. And this is where it gets a little crazy with Gen AI like that. There was a recent study by the folks over at Chroma Database that had a similar piece where they went out and they looked at embedding models. So these are models that take our text, create kind of vector representations of them, and the popular starting point when you're working with these embedding models is the multi-text embedding leaderboard, which ranks all of these models across literally probably, 80 different data sets and measures. So it's a good way to understand kind of on a broad basis which of these models is better. But what they found out is the ranking that was there in the leaderboard wasn't the same thing they found out when they actually used it. Their users actually preferred the worst performing model. This can happen. And it gets trickier. It's more than just the difference between maybe your users and that. As you're using these models, how you talk to them can affect what they say. They will shape themselves to where we talk about. This is the so-called problem of sycophancy of these models, that these models basically kiss our butt. And this has been a known problem. We've seen a lot of headlines around on this for ChatGPT's or OpenAI's 4.0 model, which has known problems with this. But if you think about it, like if your model's going to treat you differently based on your mood, like that's going to cause some problems if you're trying to do a serious evaluation of this where you need to know reliably what the model's going to do. Besides that, one of the things you'll find is that a lot of the literature out there is really focused on helping you compare different large language models against each other. So, hey, my Gemini model against my OpenAI model, which of these large language models is better? But the reality of it is most of you are building applications where you're thinking about systems where there's just one model that you've probably picked, but you have lots of other configurations that you have to choose from. So as we go through this today, I want you to think about that approach. I'm going to focus on that because one of the things are these systems are really growing in complexity as we're adding in lots of tools, lots of steps into these kind of agentic places. So the first thing I want people to do is when you get into this is size up the problem space, right? Like some things in life are easy, some things are hard. Like take that same common sense attitude towards evaluation. For some projects, you're not going to have to do a lot of evaluation. You can almost do the vibes. It's good enough. On the other hand, you're going to have some projects that are important because of the consequences of making a mistake, because of the value that you might derive from there. Or it might be the problem itself is so hard with complex reasoning. There, you're going to have to treat that a little bit differently and spend a little bit more time on rigor on evaluation. So one of the things I did for my sales team, because they think all the time about evaluating customers around RAG or retrieval augmented generation use cases, is I made a quick little cheat sheet for them to help them think through some of the facets for a RAG problem that matter. So when you're working with RAG, it matters a lot if you have kind of one document, multiple documents from different sources or different domains. Like that's one complexity. Another complexity are the kinds of questions people are asking. Are they just asking like, hey, I just need a fact kind of from this document? Or are they asking us to make a calculation across 2 or 3 documents or some analysis where I need to pull from 3 or 4 documents and then move all that information around to get to a final answer? Right? Like you can see that there's like different levels of complexity to that. And as you think about evaluation is a very fuzzy thing. This is kind of, sometimes it's hard for developer type mindsets. It's a fuzzy thing that you need to take into account. Now, as we go through this, in this talk, I'm going to focus a lot on the technical side, right? That's data scientists, developers like that. But when you're building your GenAI app, you have to also keep in mind the business and operational evaluation and metrics as well. So for business, like you could build the coolest thing possible, but if it doesn't help your business make money or save money in some way, they're probably not going to do anything with it. Same thing, like you have to think about as you build your solution, like how are you going to operationalize this? Like have you built some kind of new tooling that requires a whole room of GPUs that's going to cost hundreds of dollars an hour to be able to run? Or have you thought about kind of how to do it efficiently? Like thinking about those pieces are just as important as in thinking about your data science evaluation metrics as well. So I know it's a little bit of preaching, but I got to do it. Okay, so let's start again. I've got my personalized email. We're ready to kind of crank through the evaluation like that. And the great thing is right, we can run this through a system. We can have it set up where as new responses come in, we'll see that we'll get new emails written. But then, wait a minute. Why are these things different? I didn't change anything. Why are they the same? Why is the second one more empathetic? Well, if you're not used to GenAI, or go watch my other video, you'll see that when you're working with GenAI, there's so many things that can affect kind of how that final output, that final email is written like that. There's a lot of things that are non-deterministic, a lot of things that you have under your control, but it's a complex piece. And when we start talking about mapping, this is where, as somebody who's working on these, this is on you. Like you have to start understanding these technical pieces that come into play because they're going to affect how your application works. Now, to give you some examples of this, I worked at Hugging Face a few years ago, and one of the popular things we'd like to do is when new open source models come, we'd like to share that out with the community, let everybody know that they're out there. Many of you are great like that. You happily kind of like or retweet it, kind of glaze over it like that. But every once in a while, like somebody goes through and double checks the numbers and says, wait a minute. What you're saying about this new model, like the numbers you're saying for this particular data set, and this data set was what's called MMLU, which is a widely used benchmark for assessing kind of how smart a model is. It's based on like history tests, economics, like a bunch of like high school tests. But the numbers here that you're reporting are very different. And the thing is like, they shouldn't be. Like, MMLU is a multiple choice test. Like, if you give two people multiple choice tests, right, like when you grade it, they should, right, or if the same person takes a multiple choice test twice in two different places with the same thinking, like you shouldn't score them differently. But so like what happened? And there's a great blog post that goes into this. But basically, what the digging found out is that there's different ways of evaluating these multiple choice tests. And there's at least 3 evaluation harnesses. If you want to try some of these harnesses, check out my GitHub. I have example notebooks to run these benchmarks like that. But if you look at these evaluation harnesses, you'll see that there's slightly different wordings in terms of their prompts, kind of how there's spaces in there, or the kind of the word choices. And these slight choices, right, even like if it's a human, you think it's about basically the same, but these slight choices could affect kind of up to kind of 5% accuracy change for the MMLU score, which is enough to kind of change it on the leaderboard. And right, we all care about where it is on the leaderboard. Now, some of you are like, all right, Raj, this is ancient history, right? This is 2023. We've trained models since then. We've learned from our mistakes. Oh, brother, I wish. But if you look at, for example, 4.0, one of the latest models from OpenAI, still has a problem with prompt sensitivity. If you talk to the LMUnit folks, they'll say if people just change the tones of their prompt, right, the substance is still the same, but just the tone, it affects kind of where they show up on the leaderboard like that. This affects, if you're working with, for example, RAG, just changing the phrasing can affect both the retrieval and the generation stages, which is why OpenAI is still handing out like guidebooks, like you should tell the model to be persistent, all this kind of stuff. Like I was hoping we'd get past it, but we haven't. But this is on you. Like as you're mapping, like you have to understand which of these models are sensitive and how they're sensitive. Another example of this, and this is one that I highlighted in my video a year and a half ago, is around non-deterministic outputs. And I was hoping that we had this licked. Like OpenAI said, hey, we get it that if you give your input parameters, if you give input parameters, temperature and seed, like you'd think it'd be deterministic, but it isn't because there's like system changes. So we'll add a system fingerprint, then we'll make things deterministic. So when you have the same input, you'll have the same output. But no, they still can't get that working. And from what I'm hearing, it's going to get much harder with things like sparse mixture of expert models as well. So you'll see in the citations, I have references to even other inference platforms like VLM that all have this problem. And if you're somebody that cares about evaluation and reproducibility, like this kills you, because like that means you're never going to be able to kind of know for sure what the output is given an input. It's non-deterministic. That doesn't mean it's like going to be way off in outer space, but it adds a little bit to you. These are just some of the things that you have to think about when you're doing these evaluations. Now, the good part for you is while these are things you can think of, they're also tools. They're also options that we have when we start thinking about how can I improve my model? What can I change to do it? And we'll talk about this in the hill climbing stage of how we improve our models. Whew. So we got to do this, right? We got to figure out all these pieces like this. And this is where like the map analogy comes in to play, of thinking about and understanding in your head when you're building that GenAI map. Like what are all the different areas that it's touching? What are the things that I have at my disposal to change? So let's keep going. We got a lot of tools that we can take advantage of like that. But some of the tools are free. You can take your Dragon, for example, to good old free public dog training. But just because there's stuff that's out there that's free and easily available, would you do it? No. Same thing with public benchmarks. Yes, I have harnesses. I have code to show you how to run the public benchmarks. but they're really for measuring LLMs to give a rough idea of what they are. For your projects, you got to take the time to build out data sets, evaluations that matter for your use case. It has to be fit to you. You can't send your dragon to puppy training school. It's not going to work, okay? I get it. It's very easy to grab these benchmark data sets off the thing and think in it, but there's so many reasons that benchmark data sets are bad. Okay, so let's start by going through an example of how we can do this. You're going to start with something you're going to ask. Like in this case, I have a number of different prompts here that you're going to do where you're going to ask the model to generate to do some type of activity. What you're going to want to do is then have a gold output or ground truth or reference, whatever you call it, but this is the standard. This is where you talk to your experts, you have this written down, you get the right answer down. Now, once you have the right answer, what we can start doing is look at the model's output that comes out, and then we can compare how the model's output against the gold. Now, that comparison has a little bit of fluffiness to it. I like to use, for example, an equivalence measure, which is having a model look at both the gold and the model and say, are they basically the same? Like, it doesn't have to be like character string by string, but like, are they basically the same? For a lot of the projects I do, that works because it's saying basically if a human looked at it, would they say, yeah, it's okay. That's the type of output I need. Your projects might differ, but this is a good starting point for most people, is making sure what the model does is similar to what your humans do. Now, the great thing about equivalence is it looks a lot like standard data science where you're trying to improve upon one metric. You have one metric that you can optimize. And that makes it easy because now I can run experiments where I can try a configuration one way, try a configuration another way, and say, hey, boom. Hey, did I improve my equivalence? If I improve my equivalence, that's a better GenAI app because I'm getting closer to that human standard. Now, one thing I want you to remember about this is really measuring that forest. It's the global look. We're getting an overall view of this. But think about our dragons. Like, can you always stuff a dragon into a box? Like, it's not easy to get them to stuff into a box, and even then there's like parts like hanging out. Well, same thing for your apps here. You're not always going to be able to generate that gold answer, and we'll talk about that. Plus, there might be other aspects of the answer that you want to capture. Maybe it's not just about equivalence, but it's about tone, about style, legal compliance, many other factors that kind of come into place. So this is where we have to think about the local side. And this requires having a deep understanding of the data where we can't just look at it up high. We got to get down. We got to deal with it. We got to roll up our sleeves. We got to understand what's going on an example by example case, because that's going to give us the information where we can take our model and eke out that last bit of performance, where we can figure out exactly how to improve upon it. And a lot of this goes under the nomenclature of building tests. This is simpler than some of the language I used in the earlier video, like that. So think about, like, as your model works, you're going to have good cases, right? Like, this is a good example of it. But then you're also going to have bad examples. Now, I want you to think, what's bad about this bad example? And this is something you're going to have to do for your use cases. Now, I'm sure many of you are thinking right off the head, oh, I know this and this and this. Okay, this is an easy one, guys. I've made this like very simple for you. But the reality is most of the time, what you're going to have to do, and this is the hardest thing for all of you, is you're going to have to go and talk to the experts to figure out what is bad. You're going to have to find the domain experts, the subject matter experts, the users, the stakeholders, whatever you want to call them, the people that kind of put their boots on and go to work. Those are the folks you're going to have to talk with to understand this, because the reality is as you dive deeper into evaluation, things get much more subtle, where maybe the words have different definitions. How we've collected the data could be very different. And you have to get into the head of those end users to be able to properly think about all the things that can go wrong and have them communicate all the pieces. And I get it. We live in a time nowadays where I don't want to even talk to anybody on the phone, right? Like doing this kind of stuff is not comfortable to us, but you need to do it or find somebody on your team that has to have this connection with it, because if you can't pull that stuff that's inside those heads, how they see the world, into your evaluation workflow, your evaluation workflow is not going to capture what those end users care about, and your model project is going to be crap. Okay? Hate to tell you. So, this is a big lesson. You got to figure out how you're going to tackle it some way like that. Yes, you can do some naive bootstrapping. You can label a few of your own examples. It's good to kind of roll it up, but there's very much limitations for most of the problems we work on. We just don't know the subject area. But once you have that expertise, then it starts putting together. You can see categories of different types of errors that you're having. You can map that stuff out. We can then use that to see that, hey, what were some of the factors that were wrong about this? Oh, it was too short, a robotic tone, didn't have context and professionalism. Now, right, like now we have some meat. And let me show you kind of what we can do once we have this is we do this not only for this one example, but we have them label a bunch of examples. We can see kind of what that human evaluation is for all of that. Now, some of the folks like to build tooling. Hamel out there loves to build kind of good tooling and talk about building custom viewers. I'm a bit more agnostic on this. Like the team at Contextual I work with just uses spreadsheets. They don't even have any special annotation tooling like that. Works just fine like that. My concern with sometimes building tool is sometimes developers and data scientists rather have more fun building tooling than actually working on the problem. So don't let tooling sidetrack you, but hey, if that works for you, if that's better workflow to kind of understand and get your evaluation data working, go with it. So now one of the problems was improper length. Let's talk about building a test for this. We want to have a test, something that we can have autonomously check lots of different messages to see, did they pass this or not? And so here, I'm just using some very basic Python. Tests do not have to always be using super sophisticated stuff. In fact, often the simpler ones are often better because you can run them faster, cheaper, at a lower cost like that. But here you can see I've built a simple test to see, hey, is my response between 8 and 200 words? If so, that's good. We could build another test. One of the other issues was about tone. So here what I've done is I've used a large language model. In this case, I've used an OpenAI model. Said, read the message. Tell me what the tone is. And here's a couple of categories for it. And so this is another type of test. This is using an LM as a judge, kind of as a test. But now I get a little bit of nuance. Now I can understand the tone. Now, as you build these tests, you can now put this next to all your other information. So now I know, how the human evaluated it. I have some sense of kind of how these tones were. I can even add in here my equivalence. So how my judge was evaluating it, because part of what we should do regularly is we can use these automated tests, but we need to compare those back to our humans. We need to make sure our automation aligns with our humans, that they both see the world in the same way. Sometimes, for example, you might notice that, oh, wait a minute, like my judge is not working very well because maybe I need to change the prompts. Maybe I need to change the judge's worldview a little bit so it aligns with the human as well. Now, whenever you're using equivalence, one of the things I really like to do is use explanations. So I get not only the equivalent score, but I have it tell me a sentence, explain to me why you've given it that score. And here you can see, like, we see some things like, hey, it doesn't provide an accurate answer, it doesn't say core information. This is very useful for me as I go through and start thinking about how to react and build that. But just whenever we're thinking about explanations, I'm a big fan of explanations. I use them all over with large language models. But it's not the same thing as if you ask a human for an explanation. It's not necessarily like exactly why the model did what it does. you can think of explanations as really a separate prediction that the model is doing. And sometimes they both aren't related. Sometimes the explanation just is trying to get to the same output. And you just got to kind of take the explanations with a grain of salt. They're not always perfect. But here we go. Now we've run through lots of examples like this. I've run through like 40 or 50 examples through this. Now I can plot out, why are there failures? Right? Is the failures due to length? Is it tone? Whatever it is, I can do that. Here I'm comparing two different models. I could compare two different prompts. But now, remember we wanted to get local, we wanted to get the meat. Now we can start looking at the specific examples. For example, like what is it around these 4 examples with prompt A that's causing the tone to be off like that? Maybe I need to change the prompt. Maybe I need to change some other setting to be able to do that. And like, this is not just like, this is stuff I do on a regular basis. Like these are some crappy graphs I made the other day where I was working on a RAG use case and I used the equivalence explanations to figure out like, hey, what are the retrieval errors? What are the generation errors? What are the categories of generation errors? Like that. So like this is stuff you should be doing on a day in, day out basis if you're working in the space. All right. So you got in your head, right, this global integration tests versus these test cases, unit tests that come down to the trees. You need to think about and having both of those as you build your evaluation strategy. So let's talk about a few more tips as we go through this. The first tip here, you're going to miss the joke, is you got to compare one setting at a time. This is like an ablation, if you've heard of that from kind of scientific methodology, but it's very tempting when you're working on models to, oh, let me change the prompt and I'll change the temperature and I'll change my top K, like a bunch of things at once because you're like, you just want to get to like a good answer. But here's the problem. If you change too many things at once, you don't know what effect each one of those had on what you're trying to do. So take a deep breath, set up a way to track all of your experiments. This is where like logs and traces come into play. So that way you can just change one thing at a time and keep track of that effect through that. It's a little slower, but I promise you the slower path, this is the turtle, it will get you there faster than trying to go quickly changing lots of things. Categorize your failures. We've already talked about that. Like it's important to kind of keep track of those and you'll recategorize them over time. The third thing is favorite your examples. As you go through, you'll find interesting examples. Like the examples might hit edge cases of like where they're causing errors, or it just might give you like a really good explanation. It might be really intuitive when you look at the example and you see what the output is. Save those along the way as you go through that, because you'll need that later for either building out your evaluation data set or communicating out what you've done. Now, this was a story I told. I don't know how well it works in the video, but I don't know. Most of you have probably heard of, seen Alien movie like that. Facehuggers back, right? I have a young kid. He wants to see Facehuggers, the movie. What I didn't know, because I got on like Alien version of TikTok, is like there's a whole feminist side to Alien that I wasn't aware of. But now that I know, like it makes me look at and think about the movie very differently. Same thing happened to me for scientific research. Once you actually study how research happens in a lab, you have a very different perspective on it. And the reason I tell you this is because the story you're often told is something like this for how progress happens around your applications, where you're going to start with some out-of-the-box performance, you're going to change one or two things, and you're going to get to the next benchmark, and then you're going to change one or two more things, improve your model like that. Like there's this nice, as you put in a little bit more effort, your model gets better, and it's just a nice linear increase over time like that. Now, for those of you who've been field in the wild know that it doesn't work like that at all, right? Like it's backwards and forwards. Sometimes you'll do things, you'll work hard steadily, you don't see any progress. Then you'll randomly try something or you'll have some accident happen. All of a sudden you're like, oh, wow, I didn't think about that. And it blows up and you get a bunch of progress like that. So if you're new to evaluation, new to working in this area, just know that keep putting in the time, keep trying things. It will happen. It just doesn't always happen kind of in a nice, easily progressible way like that. Now, when you're doing this, especially with GenAI, when you're doing error analysis, it's a continual process. And the way it often works is something like this, where you're going to collect an evaluation data set. You'll do the hill climbing, you'll optimize, you'll turn all the knobs, you'll crank out on the metrics on that evaluation data set, right? You'll take it from like 60% equivalence to 90% equivalence and be really happy. But then what you want to do for GenAI apps is what we call user acceptance testing. You want to get this in front of as realistic as possible, your real users, have them use everything that you've optimized. Because sometimes, here's the thing, is what you've done there from your initial evaluation data set isn't exactly what the end customers want. And so you'll get some feedback really quickly and you'll be like, oh, shoot, right? Like these areas aren't very good, or hey, we need to add some examples around this type of behavior that we hadn't before, like that. And then you just continue this process over where you're going to do more hill climbing, you're more optimizing like that, more user testing. And you'll continue doing this until you've met your business metrics, your technical metrics. That's the eject button for out of this, is when this product is valuable for the amount of time that you've put in like that. For some things, it might be very quick. For some of them, it might be a lot more detailed. Now, as you're thinking about building this evaluation data set, one thing I like to think about is it's the same way you kind of have to eat an elephant, one bite at a time. Like that's how I like to think about evaluation data sets, where you're going to start with some basic sanity checks, right? Like is the prompt long enough? Is it the right tone? But over time, as you start hitting different areas, oh shoot, like wait, we need to add the legal compliance ones, right? Or hey, this type of behavior, we got to capture that. That's perfectly okay. That's the evolution. Don't expect to kind of have everything at once in your evaluation data set. Now, as you do this, one of the things to watch out for is making sure that you don't overfit to your eval data sets. It's very easy, and this is like what Llama did too. Like, I really want to do good on this benchmark. I really want to do good on this arena benchmark to crank your model so it's just good at that. But then you put it out in the real world and you realize it doesn't generalize. It doesn't capture all the things that we want to. So this is a real concern, especially when you like love turning knobs and love trying to improve upon it, is don't overfit to all of that. All right, let's talk about agentic use cases next. Now, the analogy I like to think about agentic is, let's think about agentic dragons. So now our dragon is capable, when it comes to a river, making a decision, right? It can make a plan. It can decide, should I fly over the river? Should I swim? Maybe something else, right? Maybe I know how to put together some logs and create a raft across the river. But this is, for me, kind of the essence of agentic, where you have to come up with a decision. You have a planning process to figure out what you do. And then you execute the tasks. Of course, you have to know how to properly fly and how to swim. It's the same thing when we look at a lot of GenAI agentic use cases. So in this case, you'll see like somebody's starting to chat, but then based on what they chat with, they're going to be going down a different route. Are they doing a product search? Are they doing customer support? Are they trying to track their package? Now, some of these workflows are going to have LLMs. Some of them could be rule-based. But I want you to think about it in terms of two steps. One is we have to make the decision here of what task to pursue. And then for each of the tasks, we have to execute it well. So your error analysis is very similar. Well, this is the Snowflake agent, similar kind of thing. There's a initial classification which says, hey, is this a SQL task or not? Bounces it out. If it is, it passes it all the way through. Now, for both of these, you still do the same error analysis. You got to assess the routing. Is it good at figuring out like where to send each task like that? Then for each of the tasks, you can measure How good are we at swimming? How good are we running? Why are we? Why aren't we? And you'll work your way through that, do that error analysis, and see where did you improve? Where there's still issues? Why are there still issues in there? And remember, things aren't going to be 100%. Like, there's always some craziness in the world that is hard to account for like that. Now, as you do this, one very seductive thing is to use frameworks. Now, we all use frameworks to some extent, right? Like, we don't code in assembly. We use higher level languages. If you're a data scientist, you use libraries like Scikit, Python, or PyTorch. We use lots of frameworks and abstractions like that. My caution, though, is in the AI space, it's moving so fast. Literally, like every 3 months, some of the tooling, some of the models are coming out with new capabilities. I've seen this with reasoning models recently. And the problem with a lot of the frameworks is they're great for kind of demos, for that initial setting it up. But when you think about the lifespan of your GenAI app, if you think about all the crazy things it has to do, this is where those frameworks often kind of break down. And then when you have to go fix a framework, it's not like your basic Python code that you had to fix. Now you have to go and understand how somebody coded up the framework and find out the bug there. So it can add a lot more to it. So I tell people to be cautious about the frameworks. A similar thing comes out is when we think about the agentic workflows. There's two different ways to do it. One way is you can kind of manually set up the workflow and just say, hey, these are all the decisions that have to be done. This is a little bit of old school where you're telling it exactly what it should do in what order. It feels like you're bossing it around a little bit, not giving it any independence. Or you can treat it as an independent, like an agent, like, hey, I trust you. I think you know how to come up with a good plan for doing this. And we have the latest reasoning models with DeepSeek R1 and Claude 3.7 that have these extended thinking capabilities. OpenAI's, I think, like O4, for example, Mini, that have this reasoning capabilities that can do this. But the question is when do you use them? And so this goes back to that early on. Like, depends on your problem. For some problems, the agentic might be great. For other problems, you're like, hey, this is way too serious. Like, I don't want to take any things. I'd rather tell it step by step, even though it's going to be a ton more work. Now, this is, I think, for something for you to think about. I see a lot of the model providers heavily pushing people towards like, hey, don't do things in a very kind of way where you're kind of plotting out everything step by step. But here's the thing, like, I don't know, like, not for every job I want to just blindly trust the Claude or OpenAI model like that. So it's something for you to think about. It's going to be a bigger issue. I think about it sometimes like cars, where there was a time when people changed spark plugs and oil, right? Now people don't do it at all. Like, how much control are we going to have about these models? How much agency are we just going to let the models do like that? And this will be a point of tension as we keep proceeding like this. Everything I've talked about today, like, this is what all the big labs are doing. Like, if you look at how OpenAI evaluates GPT-4o, right? They do vibe checks. They have automated evaluations like we've talked about. A/B testing, so right, they give some users one version, give some version. Another thing they don't do, but I often recommend people, is when you're putting your applications in front of people, include user feedback. Allow people to give thumbs up, thumbs down. Keep track of how they're using the responses that you're giving. It's very useful feedback as well. All right, couple of other points I want to just touch on here. Human evaluation. We know how to do this. We have done this for 100 years. We've worked with people, use them to collect data, get data out of them. It's a science. This is another thing, just ask ChatGPT. Like, a lot of the stuff, I've been talking about it for years, so it's all inside the models. You could probably get a better conversation that way than listening to the video. But for example, for annotation, there are well-established best practices, whether we're using, for example, multiple annotators. How do we get them to agree? How do we think about the human baseline for jobs versus what annotation is going to do? How do we set up and do training for annotation? A lot of pieces like that. It's well established. Please go out and search for it. I love model-based evaluation. We don't have enough humans to be able to look at every example that we have and kind of grade them. Models have been very useful like this. I get a lot of people are like, how are we doing this? Like, what is the deal with having models judge models? And now we have like synthetic data. Like, it feels like it's just like we're building on this like sandy base like that, but it kind of works is the thing, like when you try it. It's a growing piece that we see lots of teams kind of using automated and model-based evaluation nowadays. Pretty much every team I talk to that does evaluation is using model-based evaluation like that. For example, for RAG, it's quite often used. Ragus is one of the popular libraries where you'll have different metrics where you're going to use an LLM as a judge to measure how well it's doing in those areas as well. So I want to share with you now one interesting use of kind of model as a judge in unit tests that I've been working with. So consider the use case of you have a generative model, it has a response, and you want to make sure that the response lines up with what your users will think about it. In this case, it's financial analysts. And this has been a real use case where they want to make sure the answer lines up with how humans have been explaining the answer to these agents. And a lot of it is like making sure it's in the right style. Now, we can use a model as a judge to be like, hey, here's a prompt, like this is what the style should be like. Did it do this? That's one way, like kind of a global test. But we can also break this down into unit tests where, in this case, I came up with 6 criteria. Like I could have come up with other things. I could have come up with 10, 20. I mean, these are all flexible. This is all just what I came up with around this thing. Well, instead of just one general question, why don't we ask a question about clarity, precision, and compliance and risks to really get at this? And if we do it this way, you'll see we're able to get a much more detailed, nuanced understanding of the question in a way that I can easily grasp it. I'm not like reading tons of text to do it. I'm just like looking at the graph and saying, oh, wow, that's what it is. And here's the thing. Not only you can do that, you can combine those up together. And I have a video and notebooks on this. Put those together, and just like we do in classic data science, you have lots of individual examples. You put them together. You have a big data set. Well, run clustering. Let's find the patterns. Let's find the groups of kind of errors or mistakes that we see in this and see what are the common patterns. And it can be very useful for diagnostics like that. So unit tests are a big piece like that I want to kind of remind people and to kind of use them as well through this. And I gave the example of style, but we can use unit tests for lots of them. If you're in an enterprise, often you have to think about legal compliance issues for your responses. You can use unit tests around that, or if you're working in a RAG use case, retrieval. Here's some ones around bias and fairness. So there's so many uses for unit tests that I just want to highlight that I think they're kind of a great way to work with. Now, as you use them, again, like remember, models are generally aligned with humans, but you should always check the alignment for the particular things that you're doing, comparing them to humans, making sure things are lined up. Because here's the thing, models have biases. Yeah, they're not just plain neutral things. There's some very common biases that you should all be aware of. For example, there's a position bias. If you have a list of 5 things, the models typically will like the things that are early, 1 or 2, over items 3, 4, and 5. They bias the early items. Now, you can get around this by randomly shuffling like that, but it's something you need to be aware of. Verbosity is another one. Models like longer responses. There's one way to kind of game the LM Arena leaderboard a long time ago was use longer responses because the longer responses end up doing better on that. So think about that kind of as you go through working with these models is taking time to learn how these judges work and the types of biases they have, because that's going to affect kind of when you're using these models like that. Okay. Done a lot here. I've gone through a lot. Synthetic data generation. We use models for judging. We can use models to create stuff. A great place to do it is for questions. So if you're working in RAG use cases, you could help build a lot of evaluation questions that way. My friends over at Hugging Face kind of put out your bench that helps generate these synthesized questions that you can use like that. Now, good for questions. Be careful for things like for answers. Here's an example of a study where they found lots of hallucinations when they used it for answers. Because remember, the model's trying to do stuff like, if you want answers, stick to the ground truth. Don't have it make up that piece like that. And the biggest thing I see with synthetic data is that the synthetic data isn't diverse enough. It's very narrow, and if you train on it or you evaluate on it, your model can be narrowed by that as well. You can, with good work, broaden your synthetic data. Think about kind of making diverse prompts for it, creating different characters. There's techniques for that. But one of the things when you're working with synthetic data, just be aware. It's very easy to write a quick prompt to get lots of data, but it might not be that diverse, and that might hurt you down the road like that. All right, couple last thoughts. Evaluation tools, you'll see on my blogs, I've talked about a lot of different tools. For example, Brain Trust and LangFuse and Aries like that are kind of a few. There's a lot of great tooling out there. You don't need to do it all. Like, you can just do the basics with just logs and Excel spreadsheet. Like, there's no silver bullet like that. They're great. They can make life easier, but don't feel like you have to do that or you have to start with evaluation tooling before you dive into this. I didn't talk about it, but regression testing is another important thing as you start to mature in your evaluation, where you need to make sure that, hey, as you change things, they're not leading to reduced problems, reduced performance for things that you've done early. Similarly, A/B testing is another piece here as you're rolling out changes to see what's going on. And then I want to end with, I think we're still early on in terms of how we document or report about evaluation. When we talk about GenAI, since we use the off-the-shelf models, we don't really modify them for the most part. A lot of the documentation around kind of how we do a project is really around the evaluation, how we've judged it, how we've set that up like that. And so this was an early paper I saw around evaluations, but I think this is an area that we're going to see a little bit of maturity as we start all kind of thinking about what we need to capture for our GenAI projects around this. All right. So again, the more you can learn about the map, how GenAI works, all the technologies, all the little areas that things can go wrong, the better you're going to be at being able to diagnose and improve applications. There's metrics that are great for giving us that view of the forest, but remember, lots of times you're going to have to get in the trees, you're going to have to build test cases to really improve your models. And then we've got tons of tooling out there in the GenAI space, so good. Like everything, it has their trade-offs. Remember when you should use them appropriately like that. This talk and the slides for this talk, as well as some of the code notebooks I have that kind of highlight some of the points that I've done, are all on my GitHub for you as well. Thank you all.